Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everyone. Today, again, with the Riyadh Java User Group, we are here having a special guest, a special brother. He's already, mashallah, with us long time ago, and yet we insist to bring him again back to talk about AI. Of course, the this being like now 3 4 years, everybody's talking about AI. You know, AI is the trend, and it's really booming in all industries. So, Ahmed Misbah, how are you, brother? Welcome.
Thank you, Mu'adh. It's a pleasure to be here with you, and I'm always happy to be speaking to you and to your guests.
Thank you so much. It's really a pleasure also too from our side. Uh, Want to give a brief introduction about Ahmed. Of course, I will leave it to him to give like details in details. Ahmed Misbah is actually before I mean a speaker. He's a brother and best and one of the best colleagues really to have. We had like many discussions, many opinions together. We had also collaboration between Tech Cafe and Riyadh Java User Group like 1 year ago. 1 year ago, in Tech Cafe and Ahmed especially, they invite really brilliant and amazing people in his let's say podcast or cafe. Agile, TDDs and AI, so many wonderful topics. I really advise you guys to go and visit his YouTube channel and also LinkedIn account. Ahmed is being like one of the famous speakers here in the Middle East and also worldwide. I will leave it to him to also to speak more about this. Little bit about the session today is a bit special. Like everybody is really wondering about the categorization of AI tools, how to use them, when to use them. This is really needed, and especially nowadays when everybody like is confused how to use them and when to use them. If you have any questions, please, guys, drop them down in the box below. I'll leave it to Ahmed maybe to answer them at the end or by chapter is up to him. We do you encourage, guys, please, to ask the questions, collaborate, and share this session with your friends now, and also it will be recorded in our Riyadh Java User Group YouTube channel. Without further details, I'll leave it to Ahmed. Ahmed, stage is yours. Good luck, Tawfiq.
Assalamu alaikum wa rahmatullahi wa barakatuh. My brother Mu'adh, thank you so much for this kind introduction and for having me back on your show. As I've said, it's always a pleasure to be speaking to you and to your audience. As the session's title suggests, we will be talking today about a premise that I introduced a few months ago, titled the Human AI Lead Map. So let's get started. I'll start, of course, my brother Mu'adh has said all of that can be said. I'm just going to be doing a little bit of additions. So I have 2 decades of software development experience working at multinational firms and one of the big four consulting firms. I have a master's degree in artificial intelligence. I earned that in 2012. And I have 7 academic publications to my name in artificial intelligence. Besides the podcast, I'm also a frequent speaker at DevOps Days Cairo, the DroidCon Software Testing Days, the Africa and Middle East Conference on Software Engineering, and many other conferences. I've also recently got into book reviews, and yeah, the latest being Jeff Langer's latest book on unit testing with Java. Okay, so enough about me. Let's start talking about the human AI lead map. But I'd like to first start with a little bit of history on software development. Now, back in the 50s and 60s, um there wasn't really a software development life cycle. So we'll call that the era of SDLC before there was an SDLC. So what software developers did back then was to simply code based on available specifications. Once they've written the code, they would test it. Of course, there would be bugs. They would fix the bugs, then test again, fix and test until they have something that is ready to ship and they are confident enough to ship. And this gets shipped and goes into operations. Now, there weren't really phases here, okay? It was simply a code test loop. Write a little, check a little, and repeat. So this loop was there from the very beginning. But then in 1970, Winston Royce wrote his very famous paper managing the development of large software systems. And this is where he introduced what we know today as the software development life cycle. And he listed a number of activities that software engineers should exercise in a specific order in order to develop and deliver large software systems. And this SDLC is illustrated in the slide in front of us. Now, this is not the exact SDLC that was in Winston Royce's paper. I happen to have merged some stages together, but it basically consists of these five main activities: requirements, design, build, or coding and programming, testing, and then deployment, releasing, and operations. So this is what later on became the waterfall. Now, Winston Royce actually drew the waterfall model in order to criticize it and offer something that would work better for software development. However, this is not how things went after he wrote the paper. People took figure two of his paper and used that as the waterfall model. So, anyways, with that introduced in 1970, now we had more activities with names and an order, one direction, phase after phase. And then after that, in the 80s, 90s, and then 2001, um we had the agile software development methods. So basically, the same activities. We have requirements, we have coding, design, refactoring, testing, and operations, but ordered in a different way. And you had short iterations replacing the one long pass in waterfall. Feedback moves to the center of the work, and you've got the code test or test code loop from day one scaled up. But the activities themselves, they remain unchanged. So what we can say here is that from the early days of programming uh, till our present day, uh, we exercise the same activities but using different methodologies. And then came AI assisted software development. Um, in that new way of developing software, we basically have the same activities. However, AI just changed how to do them and how fast they get exercised and executed. And funny enough, we have two modes of AI assisted software development. We've got vibe coding, which is a mirror of the SDLC before SDLC method. So it's basically prompt, run, and fix, prompt, run, and fix. So it looks more or like the code test loop. So you have no named phases. Uh, it's a development mode that can be practiced by non-developers, and there's no fence here, and there are no guarantees. Yes, you do have speed, but without structure, and eventually no longevity. And then you've got spec-driven development. This equals to the full uh, software development lifecycle. So you've got requirements and designed, authored, kind of upfront, what we call defining the intent before the code, and then you execute a plan, build, verify cycle. Now, this is a mode of development that can only be used by software developers. It is a little bit more complicated than vibe coding, but it does have a payoff as opposed to the catch in vibe coding that you have a fence to build inside, and therefore you've got structure with speed. So now in AI software, AI assisted development, we have two new methodologies, vibe coding and spec-driven development. But you have the same five activities. Vibe coding echoes the code test cycle of the 1950s and the 1960s, and spec-driven development echoes everything that came after 1970. AI assisted software development also introduced two very interesting terms. Now, these were not exclusively introduced by AI assisted software development, those existed even before that. But let's say that they became very popular, especially within the software development community after the introduction of AI assisted software development. Now, these two modes are AI in the loop and human in the loop. Now, what is the difference between these two modes and what are they? AI in the loop is basically where humans lead the activities and the AI assists. So humans do the work and then they use the AI perhaps to criticize, analyze, or do some sort of cross checking. On the other hand, we have human in the loop, uh, which is a more familiar and popular term, especially in AI assisted software development. This is where AI drives, AI does the work, and humans oversee that work. So they review the output and they catch the error or the errors. So the modes are named after the assistant. So if AI is going to do the assistance, we say that AI sits in the humans loop. But if the AI is doing the work, then the human sits in the AI's loop. So there you have it. We've got AI in the loop and human in the loop. Now, having explained that, let's talk about some challenges in AI software development. The first challenge being human in the loop only. Now, even though uh, AI in the loop exists, in practice, uh, nobody uses it at all. It's as if we only have just one mode, human in the loop. Everyone is pushing towards AI doing all of the work and human beings sitting in the AI's loop. So basically, humans will just review whatever the AI outputs, which leads us to the second challenge, skipping human in the loop entirely. I came across this interesting cartoon drawn by Tom Fishburne in Alistair Coburn's Simplifying Software Architecture software design book. And as you can see from here, we've got an AI agent or some tool that uses artificial intelligence coming to a human being with a large volume of AI generated work that the human being should review and approve. Now, given that AI tools have become so powerful that they produce huge volumes of output, humans have stopped reviewing the work, at least manually. And this leads to humans simply approving whatever AI produces. And of course, we all know what this leads to after that. So these two challenges raise a very important question. Who should do what in AI assisted development? By who, we're talking about the AI versus human. And by the what, we mean the SDLC activities. So, who should do what in AI assisted development? From here enters the human AI lead map. So, the human AI lead map is basically a taxonomy of AI assisted software development. In simpler terms, it is a way to reason about where AI leads and where humans lead across the work of building software, and thus reaching a good balance between AI in the loop and human in the loop. This is the map, and as you can see, it is composed of 4 regions, and we've got a fifth hidden region that is not really a region, but it is there for a purpose. The first region we have is the authoring region. This is where we practice AI in the loop. And as we've said previously, in this region, human drives, AI assists. So it is where humans author the intent that governs everything downstream. Now, what are humans going to be authoring here exactly? We're going to talk about that in the coming slides. Then we have the second region, the implementation region. This is where we exercise human in the loop. This is where AI drives and humans oversee. And the exercise of humans overseeing doesn't necessarily mean it has to be done manually. Actually, no. It should be done to a great extent using automation, which was defined and designed in the authoring region. So this is where AI does the work inside human authored guardrails and specifications. The third region is the analysis region. Now, Analysis is an activity that usually sits between authoring and execution. Analysis is about feasibility studies, trade-off evaluation, algorithm comparison, root cause analysis, postmortems. And in here, you can use either AI in the loop or human in the loop. Now, if you are running a deep reasoning problem, then it is preferable to do AI in the loop. So human beings do the initial analysis, and then they give it to AI for review and perhaps criticism, augmentation, uh, etc. But if we're talking about a simple analysis, an enumeration, or some sort of pattern matching task, then we let the AI lead it and human beings only uh, review it. But the thing here is that uh, it is situational. So here we're not saying you do AI in the loop only or human in the loop only. It depends on the kind of analysis task that you're doing. And finally, we have the out of scope region. This is where AI is not a main player. This is the region where humans decide and deterministic automation runs. So AI here adds no value in the critical path. To put it in simpler terms, those are the exercises which human beings should do on their own without AI assistance. And if these exercises can be automated, they should be automated using deterministic tooling and not using AI, which is by design not deterministic. And so, if you want to summarize this map, we will say that its main principle is autonomy is earned and not assumed. Humans author, AI executes, guardrails protect. We'll talk quickly here about the fifth hidden region, which I call the AI only region. Now, this is not actually a region. This is more of a mirage. Now, we hear a lot about tools that promise complete autonomy with artificial intelligence using agents or whatever. Now, although the developers of these tools promote full autonomy, full autonomy is not really something realistic. What it is a region 2 loop inside a region 1, inside region 1 bounds. So the human is still in the fence, not in the field. So that's why we're saying there isn't an AI only region. What you have is uh, an AI harness or a loop developed in the authoring region, and then the execution happens in the implementation region. So there isn't really an AI only region here. We only have the 4 regions as per the human AI lead map. Now, this map or this taxonomy is not a law and it's not a framework. It's more of a premise. It's a lens for making deliberate decisions about the human AI division of labor, not a rigid classification. Now, how did this map come to be? I'm going to talk here about the history of the human AI lead map. Now, I started using AI in coding and other activities related to software development in 2023. And A year after that, I attended a class with Jeff Langer. He explained how he used AI in coding using something he called AI assisted development with verification, or AADV for short. This was based on a popular principle, trust but verify, and on the practice of create, assess, and execute, CAX for short. He also showed how using examples, domain specific languages, test driven development, and a style guide, which is known today as rules, made a big difference in what LLMs produced. The output was much more accurate, given that clear specs were provided using all of the stuff we've mentioned earlier. It was only then that I realized that principles, practices, and systematic approaches were starting to emerge in AI assisted development. Uh, Jeff was way ahead of everyone in this in 2024. Every other known figure in the industry, like Kent Beck or Uncle Bob, caught up with all of this years after that. And in the month that followed, three things came together. First, I applied what I learned from Jeff Langer and kept learning through my work as a consultant, coach, mentor, and advisor with software teams and companies around the world. Second, I hosted many great voices on my podcast, including five of the old gang, including Bob Martin and Alistair Coburn, along with voices from neighboring disciplines, Andrew Schaefer from DevOps, Mark Richards and Nick Tune from domain driven design and software architecture, and names like Tim Oettinger and Venkat Subramaniam. Third, AI assisted development itself was moving fast. Vibe coding, coding agents like Cursor and Claude Code, and increasingly powerful LLMs. And out of all of that, two challenges started to concern me, which are the two challenges which we have described earlier: human in the loop only, and reviews uh, review that can't keep up. Now, both roads end in the same place: AI only, and the human is squeezed out of the workflow. Wrestling with these two challenges is what made everything click. The isolated things I'd been collecting, Langer's practices, the lessons from my guests, and the patterns across all these teams started to generalize into one picture. So a few months ago, in May 2026, I finally wrote the picture down as the four-band framework for AI assisted development. I took it public on the Engineering with AI podcast with Kyle Hutchison, and we had a great discussion about it. And this is how the four-band framework looked like in May 2026. But that discussion with Kyle left me with two realizations. Um, First, this shouldn't be a framework. It should be a premise. A framework is a structure you apply. It sorts your work into boxes and asks to be used correctly. Its failure mode is rigidity. When reality doesn't fit, the framework says reality is wrong. A premise is a claim that you hold. It's a lens you reason from and argue with. It asks to be challenged. And it survives by staying useful even at its edges. You can't bend a framework. You either fit it or you don't. You can, however, bend a premise. and watching it not break is how you come to trust it. Second, what we really have are regions, not bands. Bands stack, as you see in the slide in front of you, four strata, one above the next, which implies a ranking that was never there and makes it look broken when a practice lives in two bands at once. Regions, on the other hand, are territory. They have borders, honest gray zones, and you can travel through them, which is exactly how a practice spans the map in software development and AI assisted development. And regions nest, zoom into one, and you find finer territory inside. Bands have no zoom, regions do. And from here, I decided to reframe the four band framework into the human AI lead map. And so here we are. Let's dive deeper into the map. And let's start talking about the first region in detail, the authoring region. Now, as we've said before, this is where humans drive and AI assists. No production code is written here, and this is where we exercise AI in the loop. Now, the term authoring really undersells it. Uh, Authoring is actually two engineering disciplines. It's context engineering, where we build or set up everything the agent needs to know, your artifacts, your domain language, the decisions you've made, your standards, and how it retrieves them. And you have workflow engineering, which is everything the agent does, in what order, the steps, what's get delegated, the guardrails, and which tools fire at each step. And in this region, you have basically three beats, which we'll talk about in the coming slide: collective authoring, system design and standards, and building your AI harness. Now, here we author specs, but we don't execute them. The execution happens in the second region. But right here, we define everything that the agent will use to guide and verify the execution and its outputs. Now, what does this mean for Java developers? Collaborative authoring means uh, doing things like event storming, drawing context maps, writing down our ubiquitous language or our domain glossary or project glossary if you are working with domain driven design. It's where you do user story mapping and user story writing, user story discovery, uh, splitting user stories, grooming your backlog if you have a backlog, etc. And this is where tools like Context Mapper and domain-specific languages like Gherkin uh, become useful for Java developers. Of course, I list these tools as just examples, but of course, you have a wider selection of tools that you can use. In some workshops, you can simply use stickies on a big whiteboard, then take pictures, and there you have it. B2 durable decisions. This is where Java developers start having a discussion over the architecture and the design, and representing or modeling this architecture of this or design using some sort of domain specific language like structurizer, if you're using the C4 model, or perhaps plant UML, mermaid, or any other tool that you use to basically draw your architecture and design models. It is also where you write down your ADRs, your architecture decision records, using some sort of template and on some sort of tool like Confluence by Atlassian. It's also where you write fitness functions. If this is a practice that you exercise in your process. And fitness functions are then later on automated via many tools, including ArcUnit. Last but not least, you build your AI harness. This is where you do context and workflow engineering. So it's where you write your Claude Markdown file, agents Markdown file. You route Markdown files for your skills, which will be used by your coding agent. It's where you set up the tools that you will use to implement retrieval augmented generation, or basically implement memory into your AI coding agent. And it's where you define your hooks and determine which tools your AI agent will use via MCP. And of course, you define these hooks to run TDD guards, run static code analysis using tools like SonarQube, etc. So this is what the first region means for Java developers. It's basically where you collaborate on your domain and your user stories. It's where you do architecture and design and write the guardrails for that. And it's where you build your AI harness, which will be later on used by your AI coding agent. Then comes the implementation region. Now, as we've said previously, this is where AI drives and humans oversees. And when we say humans oversees, we are not talking about manual overseeing. We're talking about automating what humans oversee. Now, in this region, your AI coding agent takes everything that you have authored in region one and starts doing the implementation accordingly. And here we have 4 beats. The harness runs, the guardrails fire, you start using spec-driven development tools, and here autonomy is earned. So you basically execute a crawl, walk, run cycle. So automation grows as guardrails prove trustworthy. So region 1 engineered it, region 2 executes it. The better the engineering, the more you can safely hand to the agent. Now, what does this mean for Java developers? Beat 1, this is where your harness runs. So this is where your AI coding agent starts implementing the production code using frameworks that you've defined in region 1, like Spring Boot. This is where your tests are written and are executed using tools like JUnit, for example, and AssertJ and Mockito. This is where your workflow runs. And this is where you have the retrieval payoff. Then your guardrails fire. The TDD guardrail starts executing the JUnit tests, which have been implemented earlier. Your acceptance tests start executing using whatever that has been implemented earlier, either using Cucumber, GVM, or Serenity. Your architecture is verified via the code that was written using ArcUnit. And the quality of your tests are measured using tools like PIT for mutation testing on Java. And this is where the use of tools like test containers, etc., are used as you move up your test automation pyramid, and you require the use of test doubles and mocks. Beats 3 and 4 mean for Java developers earned autonomy by means of using spec-driven development tools like Superpowers, SpecKit, or NWave. Now, I happen to use Superpowers. It's my favorite tool. However, I am currently exploring NWave as well, and it looks very promising. And it's where your AI agent also starts using external tools to further verify and assess the correctness and the quality of whatever it has produced in region 2 via everything that has been defined in region 1, using tools like SonarQube, for example, using its MCP plugin, etc. So again, we say region 2 is all about executing whatever that has been defined in region 1. It is about the actual writing of the production code and verifying its correctness, or basically doing validation and verification via whatever that has been defined in region 1. Let's talk about region 3, analysis. Now, analysis is all about building an understanding about something that would help us take a decision. And as we've said here, you can use both modes depending on the situation. Analysis is basically everywhere around the software development lifecycle. It is upstream. Example, when you do feasibility studies, trade-offs, trade-off evaluation, estimations, etc., or during implementation, or during debugging, or during reviews and quality checks. So this is something that happens across your software development life cycle. Now, what does this mean for Java developers? One way of looking at region 3 as a Java developer is when you use tools that would allow you to collect data that you will either analyze yourself and then give to the AI assistant to basically conduct further analysis, or criticize your previous analysis, or vice versa. You let your AI agent have access to these tools, collect the data from the tools, produce its own analysis, and uh, use human in the loop for approving any action that would be based on this analysis. Now, an example of such tools that can be used are Java Flight Recorder, Async Profiler, Jakuku for measuring code coverage via its different metrics, PIT for doing mutation testing. The results that you get out of SonarQube when you run static code analysis, logs that are being ingested into something like Elasticsearch, etc. All of these are tools that Java developers can use to produce data that can be later on used to do analysis in one of the two modes we spoke about. What analysis also means for Java developers is when you do a specific study on some system design decision that you need to take, or some technology selection that you want to do. For example, if I'm going to be doing sharding to my databases or to my database, should I go for horizontal partitioning or vertical partitioning? I take a decision and I justify it and I give it to the AI for analysis. Or, and I don't recommend that, but people can do it. I can give AI all of the context it needs and ask it to take the decision, and I will review the decision and do it myself. What analysis also means for Java developers is where you ask the AI to scan something and analyze it for you, like do a deprecated AI sweep, API sweep, or legacy, do legacy comprehension, etc. So all of these are exercises and tools that Java developers can use in the third region in whatever mode they prefer, depending on the task. Last but not least, we've got region 4, the out of scope region. Now, this is the region where AI is not a main player. And I will jump here straight into the examples. Activities like security patching, dependency updates, migrations and upgrades. These are tasks which you should not trust the AI to do. You should either do it yourself as a human being, either manually or using an automation which you yourself have implemented using a deterministic tool. But this is not something that you rely on AI upon. Now, what does this mean for Java developers? So let's say you're doing a migration, say from Spring Boot 2 to Spring Boot 3. I wouldn't ask AI to do that. It's too risky. I would use a tool like Open Rewrite to do that for me. It has predefined recipes that execute and do the deterministic transformation. And same thing goes for upgrading from JUnit 4 to JUnit 5. I would first use or I would use a deterministic tool to do so. Uh, Migrating from one namespace to another, from Java X to Jakarta, for example, or doing JDK upgrades. These are not things that I would trust AI to do. I would use a deterministic tool to do such thing. This also applies to migrating from one architectural style to another, or migrating a database. Here, humans decide and recipes execute. So here, AI is not a main player. And many of the things I've described right now, if not all, can be achieved using open rewrite. So the Java anchor in region 4 is open rewrite, including other tools, of course, like Liquibase, Flyway. Uh, all of these are tools which you can be used that can be used for migrations. Let's talk about the last region, the hidden fifth region, which according to the map is not a region at all. And the only reason why we are talking about it here is to reassert the idea that this is a region that does not exist and should not exist. Now, we are hearing about loop engineering, a practice that promises almost complete autonomy. So all you have to do is just define the loop, and the AI agent will execute autonomously until it reaches a specific intent or a certain goal with very minimal inputs from the human being. We've also heard long ago about stuff like AI ops, for example. This is where you use tools that rely on AI under the hood to basically do the operations work. So it analyzes the logs, it's able to capture errors, and it's able to do stuff like self-healing, auto-remediation, etc. And we have to be careful here that anyone who is selling AI tools or promoting AI assisted whatever, whether that be a practice or a tool, are trying to sell or are pushing for this region. So what we are trying to say here that there's no such thing as complete autonomy. Now, yes, the loops are real, and loop engineering is a real thing. The results are real. Well, loops uh, spawn or spin fleets of agents. The agents do their work, and the loop keeps running until either it hits a number of iterations or it achieves its specific goal. The voices are real. Claude Code's own creator says his job is now writing loops. And so everyone has the right to ask, is this region real? Now, in the next two slides, we are going to look at inside the loops and watch the fence. Now, this is how uh, loops look like from the inside. You've got some sort of trigger, you've got a goal defined and or a cap, and then the agents start doing their work. You've got gates that do the checks and verify the outputs, and then you reflect upon uh, the overall outcome from the agentic loop. Did it succeed in achieving its goal, or did it fail to achieve its goal? Now, the heartbeat is usually something that is purely defined by a human being. The trigger is most certainly something that is either done by a human being or something that is generated from some sort of deterministic tool. So it's something that exists in region 4 on the map. Now, when we define a goal or a cap for the AI agent so that it would verify it while the loop is running, this is something that is purely done in region 1, right? And then the actual execution of the loop, this is region 2, implementation. And then the verification are basically running and executing or firing the guardrails that have been defined in region 1, and then reflecting upon the outcome of the loop, whether that be a success or a failure. This is basically analysis, which is what you find in region 3. So in reality, looking inside your agentic loop, every activity or every step inside the agentic loop is actually one of the practices that we find in one of the regions in the human AI lead map. So there is no such thing as an AI only region. And there is no such thing as complete autonomy. It simply does not exist. And if you think it exists, then you are probably doing something more like vibe coding, more or less. So, yeah, uh, as we've said, uh, it's an illusion. Yes, there are some real things in agentic loops. Generally, they look like something that is totally autonomous, but when you look inside them, it's not really like that. So, region 5, the hidden region, is a region that the human AI lead map denies and rejects. Okay, so we have agreed that the map is a premise, it's not a law or a framework. And one of the good things about this map being a premise is that uh, you have things that can actually bend the map. So let's look at a couple of these things. So I'm going to start with the last item, uh, deny. So anyone who challenges the map by talking about an AI only region, so this can be considered as an attempt to bend the map. He or she is going to hit a wall, and using the map, uh, reaches to a conclusion that no, this region does not exist, and this is something that the map denies. So region 5 is actually one of the three things that can be used in order to attempt to bend the map. So here we're going to be talking about the first two. Uh, we're going to first talk about the practices and tools that span many regions of the map, and perhaps they traverse the whole map, as we've seen with agentic loops. And the second thing that can be used to mend the map is nesting. So this is where we zoom into one region and discover that there is another region existing in that region. So there is a sort of a recursion here. So this is where the map bends but not breaks. Let's talk about practices that can span multiple regions of the map. Those practices can include acceptance test driven development and behavior driven development. Why? Because basically you are discovering and formulating your scenarios and examples in region 1, and then implementing and executing these acceptance tests in region 2. So BDD and ATDD is a practice that spans two of the map's regions. The same thing goes for test-driven development. So you write your test list using some sort of practice like ZOM or zombies, and then you write the tests and execute the tests using the red-green refactor cycle in region 2. And of course, if you have any errors, this gets analyzed in region 3, and then the loop basically continues. And then you've got clean code guidelines and continuous design and evolutionary architectures. This is where you write fitness functions in region 1, and then you implement these fitness functions and execute them using many tooling in region 2. So these are all examples of practices that cross different regions of the map. And this is where the map kind of bends. So taking ATDD and BDD as an example, the human half, pure authoring, is discover and formulate. This is where we use three amigos, example mapping to discover our examples and scenarios and write the scenarios using Gherkin script. Then the crossing is where the Gherkin scripts are actually written, and automated tests are written for these Gherkin scripts. And then we have the actual generation and execution of these acceptance tests. And the same pattern applies for test-driven development as well. Now, here we have described practices that span different regions of the map. We also have tools that can span multiple regions of the map, like spec-driven development tools and a tool like Open Rewrite, which we have described in region 4. Now, in spec-driven development, the tools usually have different phases. Some of these phases are going to happen in region 1, and some other phases are going to happen in region 2. In open rewrite, uh, when you're authoring a recipe, the standard is written upstream, so this is a region 1 artifact. And then when you enforce and migrate, this is run as a gate in region 2 and run as a migration in region 4. Open rewrite is always deterministic, so same input should produce the same output, never AI generation wherever it runs. So doesn't this spanning break the map? The answer is no, it doesn't. This spanning only classifies the activities in the tool, but not the tool itself. So the seam holds in every call. So spanning isn't a bug in the human AI lead map. Spanning is actually a demonstration. Its most powerful illustrations are the things that move across it. Let's move to nesting, the second item which bends the map. Now, here we say that the map is fractal. What does this mean? It means that inside a specific region in the map, another region can work. Let's take an example. So let's say I am writing rules or skills for my AI agent to use. And that is going to be used in the execution or the implementation region. Okay, so I come up with a couple of ideas, and then I ask an AI tool to write the artifacts for me, which I will then use in my agent to implement some sort of guardrail or deterministic verification. Now here, we have done implementation inside the authoring, but is it the implementation of the production code? The answer is no. It's just the implementation or the automated authoring of the artifacts that will be produced in region 1. And let us not forget something here, that if you're going to use an AI tool to author something, some artifact in region 1, human in the loop applies here. So you do human in the loop after the AI tool has generated your artifact. Once the artifact has been generated, it's part of the output of region 1. So this is an example of how you can have nesting in one region. Another example of spanning and nesting, which are two things that bend the map, is loop engineering. This is how loop engineering looks like. So you define a goal, then the AI agent builds a plan, it acts upon the plan, it verifies given the guardrails that you have defined. And if the verification fails, it reflects and it iterates. And if you hit your number of iterations, or if you reach your goal, then you are done. And Boris Cherny has said that I don't prompt Claude anymore. My job is to write loops. So basically, what Cherny is trying to say here is that he no longer prompts the AI agent to produce whatever he needs to be produced in the software development lifecycle. He just defines the goal, and the AI agent writes the prompts that will be used in order to reach that goal. Now, looking at loop engineering from the human AI lead map, you will see that it is yet another spanning practice. And every loop starts in region one. So in region one, you define the goal and the bar. You build your fence, and you write the skills, and you basically build your AI harness. Now, when the loop starts executing, this is where the execution spans regions 2, 3, and 4. So region 2 is the plan, act, verify. Region 3 is reflecting, doing analysis if failures occur. And the region 4 is basically the cron jobs, the hooks, the events, basically the deterministic triggers that are used, or the deterministic tooling that is used within your agentic loop. And it pretty much looks like test-driven development, behavior-driven development, also looks like spec-driven development. Uh, these are all practices that we have said they span the whole map, including their tools as well. So their tools span different regions of the map as well. So what we're trying to say here is that in loop engineering, every loop is born in region one, and what looks like an AI only practice or tool, it's actually not like that. It is still something that spans the different regions of the map. So I'm almost done. We can make time for questions. So there you have it. This is the human AI lead map. As we've said, you've got 4 regions. You've got authoring, implementation, analysis, and out of scope. This is basically a taxonomy. So it's a way of helping you reason about what should be done by a human being and what should be done by an AI, and where each player falls in the loop. We've agreed that authoring is where you basically write the specs and build your AI harness. For Java developers, this means using tools like Structurizer, architecture decision records, context mapper, Gherkin scripts, skills, Claude.markdown, etc. Implementation is where AI leads and humans oversee using the deterministic guardrails that were defined in region 1. So this is where implementation starts to be done using frameworks like Spring Boot, JUnit 5. This is where your TDD guardrails start to fire, and with tools like ArcUnit and Pit for verifying your architecture and doing mutation testing. This is where you do static code analysis using tools like SonarQube via its MCP plugin. And this is where you execute your acceptance tests using something like Cucumber. Analysis is the region where uh, you basically do analysis. So it's where you gather data from tools like Jakuku, from logs, from JFR, from async profiler, from JDEPS or JQ assistant, and analyzing the reports or the outcomes from these tools in order to take an action accordingly. And last but not least, we have the out of scope region. This is where AI is not the main player. For Java developer, this means using tools like Open Rewrite and basically using any deterministic tool to execute something like a migration or security patching, etc. We've also spoken about uh, practices and tools that span multiple regions of the map. We've said that ATDD, BDD, TDD, clean code, evolutionary architecture, spec-driven development, and loop engineering are all practices that can span all of the regions of the map. We've also said that some regions can nest into other regions, and we gave an example of when writing skills, for example, or writing Gherkin scripts. Tools can span multiple regions as well. So regions basically classify the activities, but practices and tools move across them. Yeah, this is what the map is all about. So finally, the line that ties the talk together: autonomy is earned, not assumed. Humans author, AI executes, guardrails protect. There is no AI only region. It is just a mirage. Dispelling it is what the map is for. So that's it. If you've stayed that long, congratulations. And I hope you found this human AI map useful.
Yes, Ahmed, thank you so much. It's really amazing. Been looking for such a map because everything now, these terms, terminologies, these things are scattered everywhere. Is talking about in a different region. Now, it's really amazing initiative that you did and brought everything into like kind of a map and to see also the tools that each step is using. It's really amazing, amazing. Thank you so much, Ahmed, for this. If you allow me, can we take some of the questions, please?
Oh, yeah, sure.
Yeah. So there is a question here saying, "Hello, could you give me examples of risks in software development, of if possible?"
Oh, this is a very big question. We need to narrow it down a little bit.
Yeah. So maybe let's talk about maybe the coding risks. Yeah, in terms of implementation.
Okay. Um, I will answer the question from two perspectives. Okay. One is a general perspective related to software development in general, and another related to the human AI lead map. So, the biggest risk in software development is building a system that is not easy to change. That is the biggest risk in software development. Writing code and designing architectures is all about something called optionality. Optionality is basically how much options does this code or this design give me in the future? And how cheap are these options going to be? So, if I write really bad code and the symptoms of bad code are simply tight coupling and low cohesion, It's as simple as that. And if I design an architecture that also suffers from the same thing, tight coupling and low cohesion, I get a software system that is not easy to change. And what happens then is that when business asks me for any change, the level of effort is always 20 working days, 30 working days, 40 working days. Of course, multiply that by the number of members that are going to be involved, you get a very large level of effort in terms of man days. So basically now you have a system that is not cheap to change. And what eventually happens is that business stops asking for changes. And when you have a system that does not change, then you have what they call code rot. So you have reached a point where you have so much technical debt that you can't repay. And eventually what happens is that this legacy system gets killed and gets replaced by another system, which is easier to change. So this is the biggest risk in software development. Developing systems that are not easy to change. And we can take this risk to AI assisted software development. If you're doing vibe coding, so you're basically just prompting the AI agent to do stuff without any specifications, without any rules, without any guardrails, without any verification, you eventually end up with a system that is hard to change. And so you end up with the thing with the biggest risk in software development. Now, the way we mitigate that is by applying everything we have mentioned in this session. Okay, you apply the human AI lead map with all of its practices and tools. This is the best way to mitigate the risk of producing a system that is hard to change. Okay, so that is the first risk, the general risk. Talking from an AI assisted development perspective, I think that the biggest risk is falling into one of the two pitfalls, which I have mentioned earlier in my presentation. Now, let's go back to the slides. Yeah, there it is. This is the biggest risk in AI-assisted development. You do only human in the loop, and you don't exercise AI in the loop at all. So basically here, you don't have a region 1 and no region 4. And you think that you are exercising region 5, which should not be there at all. And the illusion of just doing human in the loop eventually leads to pitfall number 2, and that is skipping human in the loop entirely. So you tell AI what to do, it produces large volumes of outputs. Of course, your cognitive ability is unable to take in all of that output, and you end up with a rubber stamp. So approve, 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 approve. Nothing is reviewed, and you end up with a broken system in either your lower environments or your production environments. So to me, these are the two biggest risks. I hope I've answered the question.
Yeah, sure, sure. Thank you so much. Really, they are the biggest risks when things are accumulative, then things becoming very, very rigid to use and to change. Very hard to maintain the maintenance and maintainability, this stuff. Coming to the question number two, don't mind Ahmed, in
Sure.
which region AI agents are, because their work is not related to human in the loop or something like this. So
Yeah. So actually, we have answered this question in many of the slides. I take you to this slide. So basically, uh, the AI agent exists in all of the regions, and as we've said, the regions are about the activities that are being exercised. It's not about the tools and the practices. So everything your AI coding agent does falls somewhere in the human AI lead map. So this is, to a short answer to the question. You can refer back to the rest of the session for the complete answer.
yeah, sure, sure. What about if we have multiple agents and we have agent to agent and this stuff? So where do you think they fit? Also the same place?
It's the same idea. So basically, you write the specs in region one, and then you hand it over to the main agent. The main
Hmm.
agent spawns multiple sub agents in region two, and they keep executing. So going back and forth between region two, region three, region one, etc., until the loop ends somewhere and we have a result.
Ah, okay. So each agent will follow the same specs and harness that
Exactly.
that has got.
Yeah, this is a good point. So actually, you have a nesting here, which we said is one of the things that bend the rules. So yeah, each agent is going to go or span the different regions of the map as well differently. So if you have a agent that is going to run the tests, so it's going to basically use the skills that you have written to do TDD, for example. Now, the code review agent is not going to be using that skill. It's going to be using different skills that you've authored in region one. So,
Yes.
yes, so what you can say, yeah, you do have nesting here. And yeah, every region can have its own map. Yeah, that's perfectly fine.
Do you think that at one of the stage or at one of the points that there is one step that will go through all the other regions as a collective one?
Yeah, I guess so. But uh, don't forget that region 4 is a very specialized region. So I imagine that if you're writing an agent that would do some sort of migration or patching or whatever, then you're going to have region 4 inclusive. Other than that, it's usually going to be regions 1, 2, and 3.
Okay, yeah, I see. Let's take another example, Ahmed, if you don't mind. Like, for example, if I have an expert agent which is dedicated to for the code review, okay?
Mhm.
So this agent, I'm expecting it to have a full knowledge about the tests, how are written, are they fully covered or not? Secondly, the style guide that I'm using in my code. Thirdly, I am using the proper naming and conventions, which is part of the style guide. Fourth is should be also following the architecture and also
Yes.
following the patterns like controller, service, repository, and so forth. Because I am
Yes.
reviewing a code, I should be familiarly overall, like, covering all the regions. So, what do you think
Yeah.
of this?
Yeah. If you're going to be writing a review agent, okay, this is how it is going to go on the map. Okay. So you are going to define all of its specs in region one. This includes your coding standards, like your naming conventions, etc. The structure that your code should follow. Let's say you are using some sort of layered architecture and you have a controller, you have a service, and you have repositories, just as an example. And you're going to be using clean architecture, for example. So you're going to tell it how the structure is going to be written. If you're going to take this further and write tests for that structure, so you're going to instruct it to turn these guidelines or these specs into arc unit tests. Okay. Okay.
Yes.
So this is what you will do in region one. Region two is where the coding agent is going to take your specs, start writing the tests, whatever the tests are, functional tests, non-functional tests, whatever. And it's going to write the production code accordingly. And then when it comes to the review agent, uh, now it's either going to collect some of the stuff from other agents, like say the results of the test runs, in addition to skills and rules which you have defined specifically for that agent. And
Mm.
perhaps using Sonar, running Sonar Cube and coming back with a report, etc. And then based on that, you can either choose for the agent to do auto remediation, or it's going to just produce a report for you to tell it what to do later on. Because sometimes what we do is that based on the outcome, we generate more specs in region one and then run the cycle again. So
Yeah.
this is how I imagine it will go, and this is how I personally apply the map on AI coding agents.
Yeah. Makes
So
sense.
the map is basically just a guideline. Okay, it's a reminder of what you should do as a human being and what the agent should do as a machine. Yeah.
Yes. Sure. Sure. Yes. For sure. Uh, Thank you, Ahmed. I think we don't have any further questions, but last thing that I would really love, I mean, as all of us would love to see this in action or in practice, that we take some a small maybe demo project that we apply the map and we see the result maybe before and after without the map, with the map we see that a clear picture how the map will help us in producing a very like a clean code according to what I mean according I mean what we have given in each step. Plus, also, maybe if we straightforward use vibe coding, of course, we will not have like a better quality code as we do with the map,
Yeah.
I guess. So maybe if something like this with the demo, that will be very good. It will clear up all the concepts that we just saw.
Yeah. So there is actually something in the making. So when I'm confident with it, we'll definitely get in touch and we'll do a part two of this session. And we will be demonstrating a practical application of the map on an actual use case and an actual AI workflow. So yeah, this is in the making, and hopefully we'll be seeing it soon. And until then, I think that for all of those people doing vibe coding, yeah, vibe coding is a direct and straight violation of the map. Okay, so if you're doing vibe coding, you are not following the human AI lead map. You are trying to do region 5, which actually does not exist. But if you are using some sort of workflow with one of the tools we've mentioned earlier, SpecKit, JSD, N-Wave, superpowers, etc., you are applying the map one way or another. Okay.
For sure.
Yeah.
Yeah, for sure. Maybe a suggestion, if you don't mind, Ahmed, if you put this map into a repo, okay, and maybe publish it for the public and let people collaborate and maybe put their questions, maybe also because it's really really helpful and it's amazing. Really, I would love really to see it like in the public and people start using it and maybe adopting it. That will be great, really.
This is a great idea. Yeah, and actually, I'm going to put it in my to-do list. And yeah, it's a great idea, actually. Thanks for that, Muath. And you have to be the first contributor to the map.
Yeah, yeah, for sure, inshallah. All right.
Inshallah.
Any before we wrap up the session, I will leave the final words for you, Ahmed, if you would like to mention something.
I would like to thank you a lot for having me back on the show, Muath. And I love the Riyadh Java User Group. You've had many great speakers in the last couple of sessions with really great sessions. And I know you told me before we started that you have something in the making, a surprise to the Java community, especially in Riyadh. So I wish you the best of luck in that. And keep doing great stuff to the Java community.
Thank you so much, brother. Thank you. Likewise. All right.
Thank you.
So leave it here. Thank you, guys, for this contribution with us. Also, we remind you that we will have the recording in our YouTube channel. I'll leave it here now, and hopefully, inshallah, we'll see you with another session. Assalamu alaikum. Thank you so much, Ahmed.
Alaikum assalam wa rahmatullah.